So our first chapter, we're going to be talking about adaptations in maternal physiology that account for or serve the purpose of pregnancy. And we're going to talk first about the adaptations that we see in the cardiovascular system. And this is going to be broken up into two mini lectures. But in this first lecture, we're going to talk about the changes in blood volume and blood components. Excuse me. Okay. So in this first part, we're going to be talking about changes in blood volume and blood components. So all of the changes in the cardiovascular system that happen during pregnancy are adaptive in nature, and it's meant to adapt to the changing needs of both mother and baby. So during pregnancy, there is a significantly increased need for blood volume. And this increased blood volume is directed towards, of course, the growing fetus. Okay, so not only does mom need blood for herself, but she also needs blood to send to this newly formed utero-placental circulatory route and feed the baby. She also needs to support increased metabolism for herself and the additional metabolism of baby. And because of this increase in metabolism, she also needs increased blood volume to support waste excretion through urinary elimination. Okay, so because she has increased metabolism, that means that she's going to she's going to produce waste products at a higher rate. So she needs to excrete that. She also has, because of this increased metabolic rate, increased heat production. Okay? And again, this is both the metabolic rate increase in mom and also this added metabolism of baby. And so this increased heat production, the mom needs to send more blood to the skin in order to dissipate that heat, right? So that her core temperature doesn't increase. And then, of course, because she has an increased need for oxygen to serve this metabolism and an increased need to expel carbon dioxide, she actually has to increase her blood flow to the lungs, right, and enhance her gas exchange. So there are all of these reasons for increasing blood volume, and there's actually one more requirement that increased blood volume fulfills, and that's that it helps to buffer the blood loss that is normal during labor and delivery. So mom, in the course of delivering this fetus, is going to lose a considerable amount of blood, and so this expansion of blood volume during pregnancy helps to offset that birth-related blood loss. So if we look at the percentage of change, if we look at the percentage of change in different components of blood over the course of a 40-week pregnancy, okay, so y-axis is percentage of change, the x-axis is time and weeks of pregnancy. So if we look first at total blood volume, right, the solid line, we see that total blood volume increases gradually over the course of pregnancy, and the peak rise in blood volume occurs at term. Okay? And if you look over at this left axis, you see that total blood volume is getting as high as 35–40% increase. Okay? Now, if we then look at the components of blood, we see that the rise in blood volume is mostly attributable to a rise in plasma volume. Okay? And in fact, the rise in plasma volume is upwards of a 50% change. And if we look at the red blood cell mass, the increase in red blood cell mass, there is an increase in red blood cell mass, but it is much lower than the percentage increase in blood volume. So red blood cell mass is only increasing to about 15 to 20%, while plasma volume is increasing by 50%. Okay? And so because of that much more substantial rise in plasma volume compared to red blood cell count, we actually see a progressive decline in hematocrit, okay, which kind of reaches its peak around 30 weeks. And this decline in hematocrit, which here is exceeds a 10% drop, is creating a kind of hemodilution that we see during pregnancy. So even though absolute red blood cell count is increasing, hematocrit is actually decreasing just because of the hemodilution of this expansion in plasma volume. And we'll find that that hemodilution also occurs for other components of blood. So that even though the absolute amount of a component of blood may increase, the concentration actually is expressed as a decrease because of the hemodilution. So about 75% of the rise in total blood volume is actually due to, as I mentioned, this rise in plasma volume. And the rise in plasma volume is really due to two main factors. And these two main factors are factors that are going to stimulate the renin-angiotensin system. And if you recall, our renin-angiotensin system was the system that released renin from the kidneys, increased the production of angiotensin II, and that angiotensin II caused a release of aldosterone, and aldosterone caused retention of sodium and water by the kidneys. Okay, so this activation of the renin-angiotensin system is going to be the main mechanism for this significant rise in plasma volume. Okay. Now, what actually stimulates the renin-angiotensin system during pregnancy? Okay. So if we skip to the second one here on this slide, actually placental hormones are directly increasing renal activity. Renin, excuse me. So estrogen, progesterone, all of them produced by the placenta are going to increase the release of renin, okay, directly. And then additionally, we also see a decrease in total peripheral resistance during pregnancy. And this is mainly because of peripheral vasodilation of vessels that perfuse the skin, the dilation of vessels in the uteroplacental circulatory route, okay? And so this significant amount of dilation both in the uterine vasculature and in the peripheral vasculature perfusing the skin. This is going to cause a significant decrease in total peripheral resistance, which is also going to reduce blood pressure. Okay? And that in and of itself, a reduction in blood pressure under all circumstances, pregnant or not, is capable of stimulating renin. Okay? So this expansion in plasma volume is going to be due to an activation of maternal renin-angiotensin activity, sodium and water retention, which expands plasma volume. Okay? And that activation of renin is done both by the placental hormones and also the significant vasodilation occurring in the vasculature of mom. We also see a variety of other hematological changes during pregnancy. Total white blood cell count tends to increase, mostly due to an increase in neutrophils. Okay? And this tends to start around the second month, and it levels off by the third trimester, and it can get up to about 15,000 cells per cubic millimeter. Okay? And the pregnancy-related hemodilution is going to lead to a drop in the concentration of lots of blood components, even though the absolute level of those components actually can remain the same or even increase. An example of this is absolute albumin actually rises during pregnancy, but the concentration decreases by 10 to 14%. Also, absolute platelet levels remain the same while the concentration actually drops. Serum electrolyte levels like sodium and potassium drop by about 5 to 10 milligrams per liter, and plasma osmolarity drops by 8 to 10 milliosmoles. Okay? And iron levels, iron concentration can drop up to 30%. On the other hand, serum lipid, like circulating triglycerides, increase by about 40 to 60%, cholesterol increases by 40%, and phospholipids increase by 37%. Now this should make sense, okay? And this is predominantly, these rises in lipid in the blood is predominantly an effect of progesterone, and it's necessary to support the placental production of these steroid hormones. So we need lots of cholesterol in order to produce estrogen and progesterone to sustain the pregnancy. And the lipid and the phospholipids are an important components to creating the LDLs necessary for delivering cholesterol to the placenta. Now, clotting also tends to change during pregnancy. And in general, pregnancy is thought of as an acquired hypercoagulable state. Okay? So women have an increased risk for thrombosis and an increased risk for some of these conditions that we call consumptive coagulopathies, like disseminated intravascular coagulation. Okay? And if you recall, DIC refers to a condition where somebody is hypercoagulable, they have widespread activation of their clotting system, and in fact they use up all their clotting factors, and you actually end up hemorrhaging because you no longer can coagulate. So women are at higher risk for thrombosis and these kinds of coagulopathies during pregnancy because of the effect that pregnancy hormones have on the system, the hemostasis system. So there is thought to be an ongoing low-grade activation of the coagulation system in the utero-placental circulation beginning by about 10 to 15 weeks. So if you recall, the utero-placental circulation included the umbilical cord leading to baby and then leading to the placenta. And it also included the remodeled spiral arteries of maternal uterine, the maternal uterine wall, the remodeled spiral arteries that then perfuse the endometrium and the placenta. So that remodeled, those remodeled arteries in the uterine wall are thought to actually, as blood passes through them, activate the coagulation system to a certain degree constantly. Maternal fibrinogen increases by 50 to 80% during pregnancy, and much of that fibrinogen that, when activated, forms fibrin is actually found within the structures of the placenta. Tissue factor, which activates the clotting cascade whenever you have any kind of tissue injury, is found within amniotic fluid. It's also found in the decidua, and it's found in the endometrial stroma. Okay? So tissue factor, which, whether you're pregnant or not, stimulates the clotting cascade and is released when tissue is damaged. This tissue factor is actually found in much of the areas where blood is flowing through that uteroplacental circulation. In mom, her coagulation factors, several of them, especially the ones involved in the initiation of the cascade, all of those coagulation factors are elevated, and really nearly all the other coagulation factors are also elevated. A mom's APTT, or activated prothrombin time, or prothrombin time, are both decreased during pregnancy, and of course that means that it takes less time to activate thrombin and cause a blood clot. Okay? And mom's fibrinolytic activity increases early in pregnancy and then decreases closer to term. And the fibrinolytic activity refers to the ability to dissolve a clot once it's formed. Okay? So that increase in fibrinolytic activity early in pregnancy is thought to counterbalance these increases in coagulation that I just mentioned. Okay? And then this decrease in fibrinolytic activity closer to term allows for better clotting just before labor and delivery.